And once I realized I did that, I figured I might as well just do it over. Okay, so we're looking for all solutions to the equation sine x plus 1 equals 0. If it wasn't sine of x, how would you start solving this? First you'd subtract the 1. Yeah, so you'd say, well, sine of x equals -1, right? And you want to find every single possible x for which that happens. So you look at your unit circle, and you say, what angle gives me a sine of -1? And your textbook is typically letting x stand for radians and theta stand for degrees. So just there's the notation. X equals 3 pi over 2. That is sort of like the most common one, or the one that's in sort of standard unit circle from 0 to 2 pi. Does it make sense that that's not the only answer? So you could have 3 pi over 2 plus 1 more rotation around the unit circle, right? Does that make sense? Plus 2 rotation around the unit circle. And the way you represent 1 rotation or 2 rotations or backwards rotations is you say plus 2 pi n, where n is an integer. So that's plugging in the numbers 1, 0, 1, 2, etc. All those numbers. So like inputting n equals 1 means go 3 pi plus 1 rotation. Inputting n equals 2 means go 3 pi over 2 plus 2 rotations. Does that make sense? Okay. And because it said all real x, you have to somehow account for the fact that there's an infinite number of answers, and that's how you do it. Because you guys can't make an infinite list, can you? Not really, right? That's how.
You gave me an infinite amount of time.
Yeah, the vector broke into the room, so sorry, girls. Okay, find exact solutions over the indicated interval. So this one just says for x's between 0 and 2 pi. And I've got tan x minus root 3 equals 0. Well, that's the same thing as saying tangent of x equals root 3, right? Okay. So could that be a quarter, or must it be a sixth or a third? Does that see what I'm saying there? It's got to be either a sixth or a third, one of the two, because they're the ones that involve the root 3 somehow. So this first point has coordinates 1/2 root 3 over 2. The second point, then the middle is the pi quarters. This point up here has coordinates, oh shoot, I boo-booed. Yeah.
The other way around.
Yes, it is. Yes, I was just testing you guys. Root 3 over 2 1/2.
I keep making that mistake.
It happens,
That's
as
why
you
I got
observed.
4 problems wrong on the quiz.
Oh, man. So when you find tangent, you take sine divided by cosine, or the y divided by the x, right? Which of those will give you the tangent being root 3, the first one or the second one? The second one. Does that make sense? The first one, you're going to get 1 divided by root 3, which is not the same thing. So x is equal to pi thirds. Is that the only angle between 0 and 2 pi that does this?
No.
No, there's another one in this quadrant here, right? Because in that case, the sine and cosine are both negative. We'll see if I can not be dyslexic. This is negative root 3 over 2, -1/2. And this point is -1/2, negative root 3 over 2. So this first angle is 1 pi sixth past pi, so that's 7 pi sixths. The second one's a third past there, so it's 4 pi thirds. Which one is the one we're looking for?
4 pi thirds.
4 pi thirds.
Look at that, they're 180 degrees apart.
Yeah, I'm pretty sure that's going to always happen with tangent. So, at the
if it was infinite, you could do this.
yes, if it was infinite. So if we had all real x as opposed to just that interval, to get from this point to this point, you add pi. Does that make sense? From this point back to there, you add pi, right? So the way you can express that is actually just as 1, x equals pi thirds plus n pi, because you add pi to get to the next one. Does that make sense? Yeah? Okay. If those points were not equidistant, then you'd have to give them each a separate little list. We'll have an example of that next, I'm pretty sure. All right, 2 cosine theta minus 1. I prefer radians because you're gonna see radians more often, but be careful with like Alex that if it asks for degrees to give it degrees. Does that make sense? Okay, so we've got root 2 cosine of theta equals 1, right? There's this up here, Natalie, it's not in your packet, I had to make a new one. So cosine of theta is 1 over root 2. And that's not the form you're typically familiar with, so does it make sense that's the same thing as radical 2 over 2? It's too early in the morning to have the classroom change on you, huh? Okay. So in the interval from 0 to 2 pi, in which quadrants is the cosine positive?
1 and 3.
1 and 4.
Wait, so why was
Mhm.
it root 2 and over 2 the same as 1 over root 2?
Because, okay, I multiply this by root 2 over root 2,
Oh,
which gives you root 2 over, no, it's totally fine. If you don't understand, I don't mind explaining. I'm just, if I can't skip a step, I will, so it's just me being lazy.
okay.
Not a problem. It happens sometimes. I need to save my energy. All right, so which angle is going to give us a cosine of being root 2 over 2? Pi over 4. So theta equals pi quarters.
Minus pi over 4.
Oh, that's a good thing to point out. Minus pi over 4 is technically the angle that does that, but because it's between 0 and 2 pi, how do you have to state it instead? 7 pi over 4. So see how you're sort of not really wrong, you're just not quite
Yeah.
right. Okay, now what if it was all real theta? What if I didn't have that 0 to 2 pi restriction?
Then we get to use my negative pi over 4.
You could use your negative pi over 4. Then you'd say, you'd have pi quarters plus 2 pi n. That means you get this point repeatedly by adding 2 pi. Is it okay to write this one? You could write it either as 7 pi quarters plus 2 pi n,
Yes.
or you could have done what Cole said, and you could have said negative pi quarters plus 2 pi n. Those are the same thing.
Because it's not bound by restrictions.
Yeah, there's no restrictions on what the n is, so either way is okay. But you cannot list them as one single theta because those points are not an equal distance apart. Does that make sense?
Yeah, if you rotate 360 degrees, it will never end up on the same point.
Yeah. Okay, so let's try another one. Solve this one for cosine of x. I'll at least get that by myself while I update attendance for everyone who showed up late. That is, you already got the note packet because it's not in, okay, good. So if you solve for cosine of x, what do you get cosine of x is equal to? Negative 1/2, does everyone agree? Okay. So you look at your unit circle, which is like your new best mathematical friend. Okay, which quadrants is cosine negative in?
2 and 3.
2 and 3. Woohoo! You got your quadrant numbers. Yay! Okay, and is it that angle or is it that angle? It's the first one, yeah, because at that first one, the points are negative 1/2, positive root 3 over 2. What angle is that? 2 pi over 3, exactly, yep. X equals 2 pi over 3. You can say it's 1/6, 2/6, 3/6, 4/6. That's how you could figure out that's 2 pi thirds. Also down here, right, the x is negative 1/2, the y is negative root 3 over 2. So what's the other one within the 0 to 2 pi interval? I don't think it's actually, I guess you could say negative 2 pi over 3. I was just going to go with 4 pi thirds.
I just like using the negative.
No, it's totally fine. You're not wrong.
Because then I don't have to do any work.
But you just got to be careful when you do that. You
Yeah.
don't do what you did in that one where you messed up a little bit.
Yeah, because
So this one says all real x as opposed to just between 0 and 2 pi. So you need to be able to account for going 2 pi thirds in a whole nother rotation. So what do you have to add onto the end of that 2 pi thirds? Plus 2 pi n and 4 pi thirds plus 2 pi n as well. The n stands for n is an integer. So what that means is like you can plug in n equals 1, and another answer is 2 pi thirds plus 2 pi. And 2 pi is one rotation. Does that make sense? Another answer would be 2 pi thirds plus 2 pi times 2, which would be twice around. Does that make sense? And then, so all the positives account for going once around, twice around, 3 times around. The negatives mean go backwards. Does that make sense? So go 2 pi thirds, then go backwards around 2 pi. So that's why it has to be an integer, because the integers are those, the numbers like -3, -2, -1, 0, 1, 2, 3, all the positive and negative numbers that are whole. Yep, that's what it means. That's how you account for the fact that there's an infinite number of these. Yes?
Pi n is halfway around, 2 pi n is all around?
All the way around is 2 pi.
Okay.
How you can think about that is, what is the circumference of a circle? 2 pi r. What kind of, this is the unit circle, which means that r equals 1. So the circumference is 2 pi.
Oh, okay.
Does that make sense? You kind of think about it that way. It comes from the definition of radian, but that's more technical, and I think this one's a little bit easier to remember. No problem. Okay. 5 cosine of x equals 2. Cosine x equals 2/5. And I was a bit of a meanie here because,
It's domain.
no, it's not domain.
Well, I mean-
2/5,
I mean,
there
I mean
is a,
range, I mean range.
yeah. Well, the point is that 2/5 is not a number that's on your unit circle, right? In which quadrants is the cosine positive? This one and this one, right? The first and the fourth. So what you're going to have to do in these cases when you do not get a number out that's on your unit circle, the first thing is check and see, is that number less than or equal to 1? Because you could, cosine only spits out numbers between -1 and 1, right? So is that number between -1 and 1? So like question mark between -1 and 1, and the answer is yes. So then what you do is you apply cosine inverse. So you say cosine inverse of x, of cosine of x will equal cosine inverse of 2/5. So you get x equals cosine inverse of 2/5. And you're going to have to use a calculator to get a decimal approximation of that. And your book says use 4 decimal places.
1.1593.
Make sure you're in radians, and I think you must be. X equals 1.1593. Did anybody else get that?
Can you also solve it by like making the triangle itself?
You probably can also solve it by making the triangle itself, yes. So you could say that
So it's like,
this is, you could say that this is 2, and then you have a hypotenuse of 5. Yep, and then you could find that that side is square root 21, I think, in this case. So check and see if it's, but oh, what will that, the thing is that I don't think that will find the angle still. Does that make sense? Like that would enable you to find tangent or cosine of that particular angle, right? But it still wouldn't tell you what the angle was in the first place. Does that make sense? So I think that even though you could set up a triangle and determine other information about this, I don't think you can actually get the angle. Yeah.
Well, wouldn't you assume that it's perpendicular because it's like a little-
What do you mean
So-
perpendicular?
Oh, wait, no, never mind, you still wouldn't be able to.
Yeah, you still, I don't think, I think you're probably not able to. Tawny, yeah?
To change it from degrees to radians, it's that DRG let, right?
Yep. And when your calculator should say rad when you're,
Oh,
does that make sense?
and then you just click enter.
Yep, believe so. Yes.
Okay.
So I got the same answer.
You got the same answer? Okay.
Yeah, and the second one.
Okay, so here's the first answer, and so this is the number sort of up here. And the question is, what would the second one be? And so here's where we're gonna be a little bit clever. This corresponds to approximately 1.1593 radians, right? I would have another answer that was backwards 1.1593 radians. Does that make sense? But you can't give that negative number as an answer because you've got to be between 0 and 2 pi. Does that make sense? So the way to get the other answer is to do 2 pi minus that 1.1593. You kind of use like there's a little, it's not really symmetry, but there is some kind of sort of symmetry going on here too, right? To like where the numbers show up. So did you do that? What'd you get for that answer?
5.1239.
5.1239. So the point is that for certain things, you will need to use a calculator to evaluate those functions. And it's good to know that those buttons exist, but you will also have to know how to find inverses without those buttons for things that are common and are on the unit circle. Which means you can also use them to check your answers. Does that make sense as well? And they're not always going to give you all, they're only going to give you one of the answers. They're not going to give you all of them because they're functions. You put in one number, you get out one number. You don't get out two.
So how do we know whether or not we have two answers?
You have to base it on knowing where you're pretty much almost, you will frequently have two answers. I hesitate to say always, but you base it upon the fact that you know cosine is positive between 0 and 2 pi in two places. Does that make sense? And so it's at that angle in quadrant 1 and the angle in quadrant 4. So sketch 1 is part 1 is figure out where is the sign, the function positive or negative based on the problem you're given. And then once you have that, you can find the points. I think I have another one. Oh, except for this one doesn't have an answer. Okay, so take away 3/5. I know I wasn't. I'm so sorry. But we can try to apply sine inverse. Okay, multiply by 5. So I get sine x equals -3, right? Try to do, take your calculator, try to do sine inverse of -3. Just try. Yes?
Can't you just stop right there?
I want you to try just because I want to do what the calculator says. What does it say?
Domain error.
It says domain error. And why does it say domain error?
Range.
Yeah, because sine of x is never equal to -3, right? So technically this is no solution. And you can just tell me no solution once you see it. My point is that if you try to blindly apply that sine inverse function, it's going to say domain error, and that's what that domain error is telling you, that this never happens. Is that okay? All right. Awesome. All right, now the other techniques you use involve factoring sometimes and occasionally combining identities and factoring together. So with this first one, is there a greatest common factor between sine squared x and sine x? Not x, because you can't pull the x out of that sine. The greatest common factor is actually sine of x. So that's sine of x times sine of x plus 1. It's a lot like solving the equation x squared plus x equals 0. You start by taking out an x. Does that ring a bell? And then you set each piece equal to 0. It's just that the thing that's your x is now the sine. Okay, so set sine of x equal to 0 and set sine x plus 1 equal to 0. Okay, so attempt to draw a circle. Not too bad. So where is the sine 0? Where's the first place at 0? I think 0, right? Because that's the point 1 comma 0, the sine is the y there. So x equals 0. Where's the next one? Pi. And then 2 pi, right? Does that make sense? And also negative, right? So the way to write that would be 0 plus, how far apart are these points? Are they equidistant? Is it an equal distance to go from this to this as it is to go from that to that? How much distance around the unit circle do you have to go? Pi. So you could say 0 plus pi n. Do you really need the 0 plus?
No.
No, you could just say x equals pi n, where n is an integer. That gets them all.
So why did you do 0 plus pi n after you got multiple answers?
Say that again?
You got x equals 0, comma, positive negative pi, positive negative pi. How did you get from that step to the x equals 0?
So this could be written as a list that was negative 2 pi, negative pi, 0, pi, 2 pi, right? And then go infinitely in each direction. To get from one to the next, I add a pi, right?
Yeah.
And so that's what this is saying. Plug in
Oh,
different
yes.
values. It's just a more compact and technically better way of listing it. Does that make sense?
It's like saying what the pattern is.
Exactly. It's saying what the pattern is in a compact form. Exactly. Okay, how about this one? So it'd be sine x equals minus 1, which I think is this angle down here, right? Because that's the point 0 minus 1. I think that's the only place on the unit circle where sine is negative 1. Do you agree?
Mm-hmm.
So that is x equals 3 pi over 2. And to account for the fact that you could go around the circle an infinite number of times, what do you have to add? 2 pi n. Yep. Because adding just 2 pi goes around once. But the 2 pi n means go around an infinite number of times. Okay. This one's pretty similar, right? So what's the first thing you do? Take out cosine x. You got 2 cosine of x minus 1 equals 0. So first thing, cosine x equals 0. Second thing is 2 cosine x minus 1 equals 0. Okay, will cosine be 0 here?
No.
No. Would it be 0 here?
Yes.
Yes. Good. So x equals pi over 2 and 3 pi over 2. Do you see how they're going to be,
180 degrees apart.
they're 180 degrees apart or pi apart? Does that make sense? So the way you can list them together, and you can say, well, x is equal to pi over 2 plus pi n. You see how that's pi n instead of 2 pi n? Because instead of having to go the whole way around the circle to get the next, you just have to go halfway around the circle to get the next one.
And you just take whatever the first answer. You could really take.
And you could really take either one of them, right? It wouldn't be wrong to say 3 pi over 2 plus pi n. That's also correct.
Okay.
Because n is like from an infinite list of things. If you plug in the right n, you're going to get all of them eventually. So yeah, it also would have been okay to say x equals 3 pi over 2 plus pi n. That works. You could have also said x equals negative pi over 2 plus pi n. That also works. So those are both also equivalent things. And the fact that n is from this infinite list means plugging in different n's for different expressions might give you different numbers, but eventually you'll get all the right ones. Okay. So the next one is 2 cosine of x equals 1, right? So cosine x equals 1/2. What quadrants are we in? 1 and 4. Yay. 1 and 4. And so is it this angle or is it that angle? This is that steeper angle, yep. So one is x equals pi over 3. I'll worry about if I should add pi n or 2 pi n in a second. The other one down here, oh, sorry, it's just could be, it's either 5 pi over 3 or negative pi thirds. Does that make sense? So let's just use 5 pi over 3. Because then if we're stuck between 0 and 2 pi, we'll know which one is between 0 and 2 pi. Now is it an equal way around the unit circle between those two things? No, so you have to give each of them a plus 2 pi n to account for getting this one repeatedly. And you've got to give this one a plus 2 pi n to account for getting that one by adding multiple rotations around the unit circle.
Is there ever a
So-
case where you'll have 3 points there, like 4 points?
I can't think of one off the top of my head, but I'm sure that there is. Does it make sense? Do you think it's okay? Could I have said negative pi thirds plus 2 pi, and would that have been okay?
Yes.
Do you agree? Yes. Yep, that would be the same thing, right? Okay. Great. Oh, man. What is the problem with this one?
We gotta swap out a sign and cosine.
Yeah, you've got cosine and you've got sine. All the previous ones had both cosine or both sine. Does that make sense? And so this is where your favorite identities, the ones you have to know, it's also the first question on your quiz on Monday, is what are the 3 Pythagorean identities? They're the most important ones, you have to know them. So what is the Pythagorean identity that involves sine and cosine?
Sine x plus cosine x equals
Almost. Sine squared x
x squared.
plus cosine squared x, I'll just use theta, equals 1. If you take this thing and you divide it by cosine squared theta, you get the other one, which is tangent squared theta plus 1 equals secant squared theta. Does that make sense? Because sine over cosine is tangent, right? Cosine over cosine is 1, and 1 over cosine is secant, yes? If you divide by sine squared, what are you going to get? You do have to memorize those 3, okay? I think it's best to memorize the first one, which is the Pythagorean theorem, right?
And then just know how to
And then just know how to derive the other 2. That's the best way to remember them, in my personal opinion.
Will we ask which identities we're looking for?
I'm going to say find the Pythagorean identities.
Okay.
Does that make sense? Which is what, that's their name. I have no other way to call them.
Okay, but you can derive them all from the first one.
Oh, yeah, yeah.
But you can also say like an identity, so you could say that like sine minus 1.
Yes, 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 and that's what we're going to use. So since sine squared plus cosine squared theta equals 1, it lets you change sine squareds into cosine squareds and cosine squareds into sine squareds, right? Brandon, you all right?
I'm fine.
Okay, so we need to change the cosine squared theta into something else, and it's going to be 1 minus sine squared theta. So you've got 2 times 1 minus sine squared theta plus 3 sine of theta equals 0. Is it okay what I did there? Tyler, you okay with what I did there? Okay. So we'll have 2 minus 2 sine squared theta plus 3 sine theta equals 0. And I'm just going to rearrange and put the sine squared first. Does everyone realize what happened there? Okay, now from this step, I should pause and catch up and I'll have some coffee.
Is it okay that I divided by negative 1?
I was going to do that next. Yep. When you're factoring, it's typically easiest if you have a positive leading coefficient, which means the first biggest power is positive. So how you obtain that is you can divide this expression by negative 1, which changes it into positive 2 sine squared theta minus 3 sine of theta minus 2 equals 0. And you can count on something like this being on your quiz or your test, okay? Like I'm just gonna tell you now, it's gonna be there.
You multiplied by negative?
You can think about it 2 ways because they're equivalent. I multiplied by negative 1. Or I divided by negative 1. They both do the same thing, right? Because 1 is special. Okay, now since you have 2 sine squared theta, this had to come from a 2 sine of theta and a single sine of theta, right? What numbers had to be back here?
Plus 1 minus 4.
They have to multiply to make 2.
Oh, 1 minus 4.
Plus 1 minus 2. So does that work? Does putting plus 1 here minus 2 there work? You get plus sine theta minus 4 sine theta. That does work. Do you guys understand what happened there? So the trick is, kids, that to make this 2 sine squared theta, the first thing is multiply together to make that, right? And to make the -2, the last thing multiply together to make that. And now can you sign them, can you solve them both individually? So the first one we have is 2 sine theta plus 1 equals 0. So 2 sine theta equals -1. Sine theta equals -1/2. When will sine theta equal -1/2? Second and third. No, third and fourth. Yep, third and fourth. And it's either this angle or it's that angle. Does that make sense? So sine is the y part of that triangle, right? So in this, you see that that y part is shorter than that part. So I think this point's coordinates are -√3 over 2, -1/2. Do you guys agree? So what angle is that? 7 pi over 6, right? It's 1 pi over 6 past pi. Of course. And then what's the angle over here? And did I say just between 0 and 2 pi? No, so you have to add a 2 pi n to both of them. And since I didn't say 0 to 2 pi, what could you have used instead of 11 pi over 6?
Minus pi over 6.
You'd use minus pi over 6. Does that make sense? Okay. I'm not sure if I'm going to, I'm probably not going to make you fill in a unit circle in your test because I already did that. But what I'll probably do is give you a blank copy to like use as a reference. Does that make sense? Okay, yes, Tani.
So we solve for the 2 sine plus 1 equals 0, or are we going to solve for the sine?
I'm on it. Yep.
Oh.
Yeah, I just haven't gotten there
I
yet.
thought it was- okay.
No, not done yet. I'm not pausing. So you also have to solve the second one, which is sine theta minus 2 equals 0. So you're totally right. I was ignoring it for now. That's the same thing as saying sine of theta equals 2.
That's bad.
And that's bad. Because the largest y value sine gives is +1, right? So this is, or this has no solutions. So nothing comes from that part. But technically you do have to tell me that you know that that's true. Does that make sense? Okay. So those are tricky because you have to know the Pythagorean entities. And let me say one thing before we move on. We had this identity that sine squared theta plus cosine squared theta equals 1. Is it true that if I take a square root and take a square root, that's the same thing as sine theta plus cosine theta equals 1?
No.
It's a big fat no, no, no. Square roots do not distribute, okay? I mean, and you can prove it with numbers pretty easily, like, here we go. 3 squared plus 4 squared. If you, this is like order of operations, and technically you do the stuff inside the parentheses first, and that square root sign acts like a parenthesis. Does that make sense? So what's 3 squared?
9.
What's 4 squared?
16.
It's 9 plus 16.
25.
And what's 25? Square root?
5.
5. If you try to apply the bogus root to the first thing, root the second thing, what do you get?
7.
And since those two things are unequal, this like questionable operation is false. It does not work. It works for when one of the numbers is 0. I think that's like the only instance that it ever works. So certain things don't distribute, powers especially. Like squaring something also didn't distribute the power over addition, right? Okay. Whoa, this one seems weird. Tan x equals -2 sine x. So whenever I see something weird that involves things that are not sine and cosine, my first method, go back to sine and cosine. Does that make sense? So this is sine x over cosine x equals -2 sine x. Does that make sense? Next method, probably multiply that cosine out of the denominator, right? So sine x equals -2 sine x times cosine of x, right? and then probably get the stuff on the same side, and I don't like negatives, I'm gonna move the negative stuff on the other side. Does that make sense? Okay, so that'd be sine x, sorry, got too excited, plus 2 sine x cosine x equals 0, right? Does that make sense? That's a little bit why you had these sections on simplifying expressions and finding equivalent expressions, right? To sort of show you how you can mess with these things so you can solve equations with them. All right, what can you do next?
Take out sine of x.
You can take out sine of x. Okay. That's not so bad so far, right? And then you can solve sine x equals 0, and you can solve 1 plus 2 cosine of x equals 0 individually.
Sine x of 0, because we had in the last problem, is that answer always?
Yeah, it's not gonna change.
Okay.
Yeah. So in the last problem, what did we get? That sine x is 0 at pi n? Remember that?
Yeah.
Pi n? Because it's 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and all the negative pi's as well. So yep, all the whole number pi's will be pi n.
So in the test, if we just have it.
Yeah, if you just have it memorized, although it's good to both know why and have it memorized, right? But it could be you didn't have it memorized because you've done so many problems, you're like, it's been beaten into your skull. The other one is going to be cosine of x equals what? -1/2. Spectacular. So what quadrants we're looking at first of all?
3 and 2.
3 and 2. Sure, awesome. So there's 2 pi thirds, 4 pi thirds, 7 pi 6, and 5 pi 6. So this first one's coordinates are -1/2 positive root 3 over 2. So you already know which angle it is then, right? So what angle is it? 2 pi over 3. I think that's what you meant.
Yeah.
Yeah, I believe you. Plus 2 pi n, because we can go around the circle repeatedly. And the other one will be this angle, which is what? Great, 4 pi over 3 plus 2 pi n. Awesome. The one thing you have to be just like a teensy-weensy bit careful of, and this is just a little, it didn't happen on this problem, but it could come up. So be careful that no answers make cosine of x equal to 0. Why is that a problem? Why is cosine x being 0 a problem? It came from a denominator. Does that make sense? So technically, I don't think we have any problems here, as in none of these numbers will make cosine 0. Like the only candidates would be pi n probably, and cosine isn't 0 at those places, right? But it might be possible to find extraneous solutions when you do stuff like this. So everything when you solve it has to work in the original equation, and since the original equation has a denominator, you've got to make sure that the stuff that you plug into that doesn't make the denominator of that equation 0. Does that make sense? Okay, so just be careful. It didn't happen here, but it could. Oh, phooey. So what's the problem with this problem? Yeah, this one has sine of 2 theta, and the other one just has theta. And so you can't take out a greatest common factor because sine of theta and sine of 2 theta are different things. Does that make sense? So you have to somehow change that sine of 2 theta into things that have regular theta, as in not a doubled theta. And that was section 7-3, which was the double and half angle identities. This is actually one that if you take calculus 2, you have to actually know this one. So sine of 2 theta is 2 sine theta cosine theta. I'm not going to make you memorize that for your quiz, but I think I'm going to make you memorize it for your test. Okay? Just because that's one that comes up again, and so since we're supposed to be preparing you for stuff that comes up again, that's one of them, okay? So, but I will give you a list. And that's helpful because when you input this, you have 2 sine squared theta plus 2 sine theta cosine theta equals 0. And now do you have a greatest common factor?
2 sine theta.
You have 2 sine theta times sine theta plus cosine theta. But for your quiz on Monday, that formula is on the identity sheet that I gave you. But the thing is that there's so many identities, it's really hard to pick out which one to use. You guys agree with that a little bit? There's so many different things you could use, right? And they gave you so many different equivalent things, it's really hard to choose which one is the appropriate one to apply in various situations, right? Okay, so now solve 2 sine of theta equals 0. Does that 2 really matter? No. So sine theta equals 0. And I think we did a whole bunch of that. So it was theta equal to, that was the pi n one, right? Just going to verify it's at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, blah, 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 blah.
Oh, so whether it says sine of x or sine of theta.
Doesn't matter. Your book, because I'm ignoring degrees because I hate degrees and I like radians better, and you're going to see more radians than degrees in your classes. Your book, when they use theta, they mean degrees. So just watch out for what the directions say. But I'm going to want you to give radians. So like Alex might say, Alex will tell you what theta or x is supposed to be. So if this was in degrees, does it make sense that that would be 180 degrees n? You just put in the equivalent angle for the radians.
Because theta is the symbol that you always see in the corner of a triangle, right? So it's
Yeah.
between the
But I mean,
angles of it.
radians are also angles, so it's not as if it's only your textbook that has done this. I've never seen any other textbook that says, oh, when I use theta, it must be in degrees. When I use x, it must be in radians.
Okay.
They just were saving themselves some time with their typing, I think. Does that make sense? To make it consistent. Okay, but I think also since you're more familiar with degrees, we're kind of going to go with radians because I want you to become more familiar with that instead. Now the next one, sine theta plus cosine theta equals 0. Now if two things add to 0, they have to be opposites. Does that make sense? As in, another way of saying that is sine theta is negative cosine theta, or saying that negative sine theta equals cosine of theta, right? That they're the same number, but they're the opposite sign. So would the angle of pi over 4 have that property? No, at that point, the sine and cosine are equal. They're both root 2 over 2, right? At 3 pi over 4, what are the coordinates there? Negative, and positive root 2 over 2. Would those two numbers add to 0?
Yes.
Negative root 2 over 2 plus positive root 2 over 2, that would add to 0. So one potential is theta is 3 pi quarters, which if you were in degrees, I'm pretty sure is 135. Yes?
When you were factoring, shouldn't that be a 1 plus cosine?
Because it was sine squared.
You took out a 2 sine theta,
I took out a 2 sine theta.
and so shouldn't it be sine theta plus 1 time, or, I'm kind of confused as to where you got the sine theta plus cosine.
Sine theta came from the sine squared theta.
Okay. If you had 2x squared plus 2xy, what's the greatest common factor? 2x? Okay, what's left in the parentheses? No.
Or
X plus y. Okay, good.
oh,
Exact same idea here, right? Does that make sense? Does that help? Okay, good. And, okay, so 3 pi quarters. What's the other one? 7 pi quarters. Are those numbers or those angles an equal distance from each other? Yes, they are. So do you need 2 separate lists then? No. So just say plus pi n. So I'm also going to be expecting you to be able to distinguish when you need 2 lists and when you just need 1. Does that make sense? So you'll have to know. Okay.
So then
How do I know just to do 1 list? Because if I can add a constant angle to go from this to that and keep going around the circle, then I know I only need one list. So you see, to get from this point to that point, you can add pi. And to get from this point to that point, you can add pi again. But if it were, say, this angle and this angle, I'd have to add something to get here and then something different to get there.
Oh, okay. So
Does that make sense?
both angles down, and then every time they go around.
Yeah, exactly. Whereas this one, I can get from one to the other by just going halfway around.
Okay, and so for this one, you put pi in, meaning you only went halfway
I
around.
went halfway around the circle, exactly.
Okay, so it means that there's a point halfway around the circle
That also works. And does it make sense that 7 pi quarters is that point? Because at that point, the x coordinate is root 2 over 2 and the y coordinate is negative root 2 over 2.
Okay.
And also those two numbers add up to 0 or are the opposite of each other. Okay. How far did I get? 6. Okay, 7. Oh man, 7's tricky. You ready? Oh, no, not there yet. 6b. Sine x plus cosine x equals 3. So this is more of a reasoning question than anything. What is the biggest value of sine x? Is 1. What is the biggest value of cosine x? 1. What is the biggest value of sine plus cosine in that case? 2. Does that make sense? So can sine x plus cosine x ever equal 3? No, that's no solution. So, reasoning. Does that make sense? Okay. All right, how's this one a little bit different? Instead of x, it's 2x. Does that make sense? Okay, so here's how we're going to deal with it. We're going to ignore the fact it's 2x for a little bit, okay? We're just going to pretend. We could even make a substitution. We could, like, let u equal 2x. Does that make sense? Just to kind of, like, forget about it for a second. Is that okay? Let's do that. 4 cosine squared of u minus 4 cosine of u plus 1 equals 0. The substitution idea comes up again in Calculus 1. Use it to do something called the integral, but okay. And so does it make sense that the options you have that made 4 cosine squared u, either it's 2 cosine of u and 2 cosine of u in the other place? It could have also been 4 cosine of u and a single cosine of u in one place. Does that make sense? But I think that this is, and how would you make, what numbers multiply to make positive 1? 1 and 1, or
Negative.
negative and negative. And why does this one have to be negative and negative? Because the negative in the middle, right? And then just multiply that together in your head quickly. Does that check out to be what the multiplied version is in the step above? You get 4 cosine squared, right? Minus 2 cosine makes minus 4 cosine, right? Plus 1. So yes. Awesome.
Is there a possibility that
There is a possibility, but not in this case. Does that make sense? So yes, it is possible, but it just didn't happen in this case. Like if you had tried 4 cosine of u minus 1 and cosine of u minus 1, that multiplies to 4 cosine squared u minus, looks like 5 cosine of u plus 1, which doesn't have the right middle term. Does that make sense?
So as those guys start getting bigger, like how do you break them? You
You want a general way to figure it out, and I think it's just experience and checking yourself. Does that make sense? Like the more patterns you see, the better you're going to get at figuring them out quickly. So in general, if this middle number is big, it tends to be the 4 and the 1. But I mean, that's kind of a general principle as opposed to a hard and fast rule, because there's other things that affect this. And most of the ones you're going to see in this lesson are really easy to guess and check. There aren't that many possibilities. Does that make sense? Okay. So let's solve 2 cosine of u minus 1 equals 0. It's the same thing as saying cosine of u is a half, right? Okay. So at what angles is u going to be, what angles are going to give us a cosine of 1/2? Pi over 3, Also 2 pi over 3, right? And I'm just going to list a few more of them because I only have to go from the interval from 0 to 2 pi, but I'm not sure what that 2x is going to do to stuff. Does that make sense? So, but I do know I'm in the positive interval, so I'm only going to look at positive angles, okay? So if we did pi thirds plus a whole nother rotation, what's that going to be? So it'd be pi thirds plus 2 pi, 7 pi thirds. Do you agree with that? What would 2 pi thirds plus 2 pi be? 8 pi thirds. And what if you'd added on another 2 pi? So plus 2 pi plus 2 pi. Okay, great. 13 pi thirds, and that would have been, I think that's going to be 14 pi thirds, right? Okay, yes.
Isn't 2/3 negative 1/2?
Oh no! Oh no!
Yeah, I was confused there for a second.
Oh, that's why you should speak. Because it's early and I make mistakes. Okay, pi thirds and this one, which is 5 pi thirds. I was so focused on the other part, I boo-booed. Moral of the story, pick your quadrants first. Okay. The next one still is 7 pi thirds, right? And then after that, you'll have 11 pi thirds, and then what would pi thirds plus 2 pi would have been? So pi thirds plus 2 pi twice, the same thing as pi thirds plus 4 pi, right? So that would be 13 pi thirds, do you agree? And we'll just do one more. Well, we can stop there. Okay, so u is pi thirds, 5 pi thirds, 7 pi thirds, 11 pi thirds, 13 pi thirds. Okay. And there's more, but we'll just stop the list there. What was u actually equal to? 2x. So 2x equals pi thirds, 5 pi thirds, 7 pi thirds, 11 pi thirds. What do you have to do to get that x by itself? Divide it all by 2. Will that make it 2 pi thirds, or will it make it into pi 6? Pi 6, yeah. Half of a third is a sixth. So x is pi 6. Is that between 0 and 2 pi?
Yes.
Yes. X is 5 pi 6. Is that between 0 and 2 pi? Is 7 pi over 6 between 0 and 2 pi?
Yes.
Yes, it is. 11 pi over 6 is between 0 and 2 pi, right? And the next one, 13 pi over 6, is that between 0 and 2 pi?
No.
This one all of a sudden is too big. Does that make sense? So,
An easy way to see it is whenever you get over 12 pi.
yeah, exactly. Anything bigger than 12 pi over 6 will be outside of your 0 to 2 pi range. Here's a general rule of thumb. The fact that it was a 2x means you have to go around your unit circle twice in this step to get all of the possible answers. If it was 3x, you'd have to go around the unit circle 3 times to get all the possible answers. Okay?
So how come in the beginning, so the answer would be those lists that you have right above,
Mm-hmm.
but when you're looking at it, is it possible to solve it by, because they have the same thing in the parentheses, to pull out like to move the 1 to the other side and then pull out 4 cosine of 2x?
Ask me after, okay? Because I'm not quite interpreting what you're saying right now. Yep. Okay. So, 4 sine squared x minus 3 equals 0. How would you start?
Add 3.
Add 3? So 4 sine squared x equals 3. Then next you would divide by 4. And then next you would square root, yes. And the one tricky thing here, don't forget the plus minus. Does that make sense? If you forget that, you're going to miss half of your answers. So sine of x is plus or minus root 3 over 2. Does that make sense? Okay. So you got to figure out when is the sine root 3 over 2. That's the y, right? So this is the point root 3 over 2 1/2. This is the point 1/2 root 3 over 2. So pi thirds is one place, right? So we're technically solving sine x equals positive root 3 over 2 and sine x equals negative root 3 over 2, right? So where is the other place that the sine is positive root 3 over 2? That would be where it's negative, but that's also an answer. Does that make sense? Oh, no, never mind. You're right. Of course it's 2 pi thirds. Yes, I dyslexic. Good job. Sorry. Okay, what's the next one? So you've got pi thirds and 2 pi thirds. You also have x equals this one. The sign is negative root 3 over 2, right? So that would be 4 pi thirds, right? And this one, which is 5 pi thirds. You agree? We? Okay. So pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Can you do one list? No. You can do 2 lists, yep. One list would be pi thirds plus pi n. Which other point is that going to catch? 4 pi thirds. Another list could be 2 pi thirds plus pi n, and what's that going to catch? 5 pi thirds. Okay, so we have time to do one more. Pick which one you want. Do you want to do B? Might be have time for B. How about 9A? You're scared of that? So perfect, that's what you do. If you're scared of it, that's how you pick. Okay, so what do you think the first thing you do is? Sine 2x. You make it into
2 sine cosine.
you make it into 2 sine x cosine x. First thing is you get rid of the fact that there's a different angle inside of the sine. So 2 sine x cosine x. Is the root 3 the thing that's scaring you? Is that what's scaring you? No? Okay. You weren't scared? Okay. Okay. Does it make sense then you can take away the root 3 sine x and put the stuff on the same side? You can't divide by sine because sine could have been 0 and division by 0 is bad. Okay, what next? You can factor out a sine. Okay, so now we're solving sine x equals 0, which we've done like 10 times today. So what's the x? Pi n, right? And then we're solving 2 cosine x minus root 3 equals 0. And you see why the root 3 is kind of important now, because you're going to be looking for where cosine of x is equal to what? Root 3 over 2. Okay, so cosine is positive in quadrants 1 and 4. I learned my lesson. I'm going to do it every time now. Is it pi 6th or is it pi thirds that the cosine is root 3 over 2? Pi 6, the first one. And also at negative pi 6 or 11 pi 6. And for both of those, they're not an equal distance apart, so you're going to have to add 2 pi n on both of them.
You combine combine them as one and say x equals plus or minus pi 6 plus 2 pi n?
I think you could. Let's just not for now, but I think that would be okay.
Because minus pi 6 is.
Yeah, no, I agree. You probably could.